Welcome back to the deep dive. I want to start today by asking you to do something a little weird. I want you to close your eyes, assuming you aren't driving, of course, and really picture your car.
Mm-hmm.
Not, how it looks sitting in the driveway with the sun hitting the paint, but what it actually is underneath it all.
It really is a deceptive image, isn't it? We
Yeah.
still look at cars and we see, four wheels, an engine, a steering wheel, but the reality is just so much more complex now.
It really is. I mean, in the modern era, a car isn't really a machine anymore. It's basically a data center on wheels.
That's a great way to put it.
You've got servers, sensors, miles of cabling, and millions upon millions of lines of code just keeping you on the road.
And that shift from machine to computer completely changes how we have to think about risk.
That is exactly where we're going today. We've got a stack of documents here that paint a pretty intense picture of the automotive future. We're diving into the U.S. Department of Commerce's Bureau of Industry and Security, better known as BIS, and their Connected Vehicle Rule.
Specifically, 15 CFR Part 791.
15 CFR Part 791. It sounds incredibly dry, but the implications are just massive. Now, for context, even though we're talking about this in early 2026, this rule officially kicked in back on March 17, 2025.
And the industry is, I would argue, still reeling from it.
For sure. Our mission today is to understand why the U.S. government suddenly cares so much about where your car's software comes from and not just what it does.
It is such a fundamental shift in mindset. If you look at the last, say, 10 or 15 years in tech, the entire industry, auto included, has been obsessed with one question.
Is this software secure?
Exactly. Is it secure?
Meaning, does it have bugs?
Mhm.
Can some teenager in a basement hack it?
Precisely. We spent a decade hunting for vulnerabilities like Log4j or, SQL injections. We were looking for flaws in the code itself. But this BIS rule, it changes the question entirely.
Right.
The question is no longer just, is it secure? The question is, who touched this software?
It's a shift from security to provenance.
That is the key word, provenance.
Usually when I hear provenance, I'm watching Antiques Roadshow, and someone is trying to prove a dusty chair belonged to Louis XIV or something. It feels like a history term, not a tech term.
But it's actually the perfect analogy. In the art world, if you can't prove the history of ownership, who held the painting, where it's been, whose hands it passed through,
Then it's worthless.
it's worthless, or worse, it's considered stolen. The BIS Connected Vehicle Rule is demanding that exact same chain of custody for the code that's running your brakes and steering.
So, okay, let's dig into the why then. Why is who wrote it suddenly becoming just as big a deal as does it work? I mean, if the code functions perfectly, does it really matter if it was written in Detroit or somewhere else?
According to the Department of Commerce, yes, it matters immensely. It all comes down to national security.
Oh,
The rule is specifically targeting supply chain risks associated with foreign adversaries. The text is very blunt. It names the People's Republic of China and the Russian Federation explicitly.
so this isn't some vague legislation. They're naming names.
They are. The concern is leverage. If a foreign adversary has influence over the software in your vehicle's connectivity systems, that access could be weaponized.
We're not talking about stealing credit card numbers here, are we?
No, not at all. We're talking about the potential to disable vehicles, track movements, or manipulate critical systems on a mass scale.
That is a terrifying thought. You could theoretically gridlock an entire city without ever stepping foot in it.
Exactly. And that is why the scope of this rule is so specific. It targets two main areas: vehicle connectivity systems, or VCS, and automated driving systems, ADS.
Okay, let's break those down for the listener. VCS is the stuff that talks to the outside world.
Right. Anything that connects the car to a network, so Bluetooth, cellular, Wi-Fi, satellite. And ADS is, the automated driving piece, the systems that actually control the car's movement.
So the brain and the mouth of the car.
That's a good way to put it. The rule restricts transactions involving VCS hardware and what they call covered software if that software is designed, developed, manufactured, or supplied by entities that are owned by, controlled by, or subject to the jurisdiction of those foreign adversaries.
Covered software. Okay, that sounds like some legal jargon we're going to need to dissect. But before we get into the weeds of the definitions, I want to establish the stakes for the person listening right now. Maybe they aren't an auto CEO. Maybe they're a developer, or they work in compliance, or they're just a tech enthusiast. Why does this rule change their life?
Because the era of don't ask, don't tell in software is over. It's just done. If you work in tech, auto, or compliance, you can no longer just ship code because it works. You have to prove its lineage.
Have to prove where it came from.
You have to verify that no prohibited entity had a hand in creating it. It moves the entire industry from a trust me model to a prove it model.
That sounds incredibly difficult. I mean, modern software supply chains are just, they're so messy. It's like a bowl of spaghetti. You grab one strand, and you realize it's connected to 5 other meatballs you didn't even know were there. A developer pulls in a library, which pulls in another library, which was maintained by a guy who, I don't know, moved to Moscow 3 years ago.
That is the nightmare scenario. And the thing is, BIS knows this.
So how do they expect companies to enforce it? Are they forcing everyone to use some specific government scanner? Like, please insert your code into the Freedom Scanner 3000.
No, and that's actually the clever and the challenging part of the regulation. They didn't mandate a single technical tool. Instead, they established a framework built around something called Declarations of Conformity.
Declarations of Conformity.
Yeah.
That sounds incredibly bureaucratic.
It is, but it has teeth. Think of it like a sworn statement or an affidavit. The automakers and importers, they have to certify legally that they haven't engaged in any prohibited transactions.
Okay, but can't they just sign the piece of paper saying, we promise we didn't use any Russian or Chinese software, cross their fingers and get back to work?
Well, if they do that, they are taking a massive gamble. You can't just sign the paper and hope for the best. The rule places the burden of proof squarely on the certifying entity. You have to maintain documentation to substantiate that certification.
So if the BIS comes knocking and asks to see your homework,
You have to show it. If you sign that declaration and it turns out there's prohibited code in your car, I didn't know, is not a defense. You are liable.
it's like math class. Getting the right answer isn't enough. You have to show your work to prove you didn't cheat.
Precisely. And this highlights a huge problem with how the industry currently operates. Right now, a lot of compliance just relies on supplier assurances. You ask your vendor, is this safe? They say yes, and you file that away.
But under this rule, that's not enough.
Not nearly enough. You need evidence. The organizations, they need to be able to answer some really foundational questions with absolute confidence.
What kind of questions are we talking about?
First, just what software is actually in the vehicle.
Which seems like such a basic question, but in a car with 100 million lines of code, that's actually really, really hard.
Extremely hard. Second, which parts of that software qualify as covered software under the legal definition? And third, and this is the killer, who authored it and under what jurisdiction?
Who authored it?
Yeah.
That's just wild. I mean, some of this code might have been written 5 years ago by a contractor who doesn't even work there anymore, or it's a subcomponent of the subcomponent.
That's the reality compliance teams are facing. They have to map the genealogy of their code. And this brings us to one of the biggest surprises in the rule. When we usually talk about software supply chain security, what's the boogeyman? What's the one thing everyone is afraid of?
Oh, open source. Definitely.
Yeah.
Everyone remembers Log4j. The idea that some random library maintained by a guy in Nebraska can bring down the entire internet. It's always the open source stuff that makes the headlines.
Right. Usually, the focus of every security briefing is manage your open source risk. But here's the twist. The BIS rule explicitly excludes open source software from the definition of covered software.
Wait, hang on. Really? The government is saying we're worried about national security, Chinese and Russian influence, but that open source stuff, that's totally fine.
With a condition. The source code must be freely available and redistributable in its entirety.
That just feels so counterintuitive. Why would they exempt the Wild West of code?
Think about transparency. If the code is truly open source, anyone can inspect it. You can see who wrote it, you can see what it does, you can see the whole commit history. The origin is public record.
It's hiding in plain sight.
Exactly. The risk of a hidden backdoor is perceived to be lower because, theoretically, thousands of eyes can look at it.
That makes sense. Sunlight is the best disinfectant, as they say. But there has to be a catch. When does open source become a problem?
The gotcha moment happens if that open source software has been modified for proprietary purposes and is not shared back.
The fork. So if I take an open source library and I tweak it to make it run faster on my specific engine hardware, and I keep those tweaks secret,
Then it is no longer exempt. It becomes covered software.
and now I have to prove its origin.
Exactly. And just think about how common that is in the auto industry. Automakers are constantly tweaking open source kernels and libraries to squeeze out performance or fit specific hardware constraints.
And they almost never push those changes back to the public branch.
Rarely, because they view those tweaks as their competitive advantage, their secret sauce.
So the moment they optimize that code, they are walking right into a compliance trap.
Correct. And this completely flips the script for compliance teams. Historically, governance programs spent all their time on open source license compliance. Did we credit the author? Are we allowed to use this? But under this rule, vanilla open source isn't the primary regulatory concern. The regulatory gun is now pointed squarely at commercial libraries, proprietary middleware, and those black box binaries you get from suppliers.
The stuff you can't see inside.
The stuff where you have no idea who wrote it, and your supplier just says, trust us, it's fine.
And that, I imagine, leads us to the technical hurdle. Because if we need to see inside these proprietary black boxes to certify them, we need tools that can actually do that. But from what I'm reading in these articles, our current toolkit is lacking.
Lacking is a very polite way to put it. The tools we've all been using for the last decade just aren't built for this.
You're talking about the security scanners.
Yes. We call them SCA, Tool Software Composition Analysis.
Right, SCA. I mean, these are the standard industry tools. They scan your code and tell you, hey, you're using an outdated version of this library, you should update it. Why don't those work here?
Well, think about how they work. Legacy SCA tools were built to find open source packages. They work by looking at your code and comparing it to this massive public database of known open source projects. They're looking for fingerprints.
Like, oh, this file matches the fingerprint for OpenSSL version 3.0.
Exactly. That seems straightforward. But what happens if you're using a proprietary commercial library from a vendor? Is that in the public open source database?
No, of course not, because it's proprietary.
Right. So the SCA tool scans it, finds no match in the database, and effectively says, I don't see anything here. It's completely invisible to the tool.
That is a massive blind spot. The tool gives you a clean bill of health because it simply can't see the patient.
And it gets worse. We have to talk about how automotive software is actually built. Cars are not web apps. In a car, for performance and safety reasons, software is often statically linked.
Okay, for the non-coders listening, we need to break that down. What is static linking, and why is it such a headache for these scanners?
Okay, the best analogy is, imagine you're baking a cake.
I can do that. I'm with you.
If you have a bowl of flour, a bowl of sugar, and a bowl of eggs all sitting on the counter, you can easily identify them, right? You can pick up the egg and look at the brand stamped on the shell. That's essentially dynamic linking. The parts are separate until the program actually runs.
Ooh, okay, makes sense.
Static linking is like actually baking the cake. You mix everything together, the flour, the eggs, the sugar, and you put it in the oven. The compiler, it mashes them all into a single optimized block. Once that cake comes out of the oven, can you look at a slice and point to exactly where the egg is? Can you tell me which farm that egg came from just by looking at the cake?
No, it's just dot cake. The ingredients have lost their individual identity.
That is static linking. The compiler takes all the different libraries and code snippets, mashes them together into a single binary file, a blob, and it deletes all the labels to save space and make it run faster.
So the SCA tool looks at this blob and has absolutely no idea what ingredients are inside.
Precisely. These post-build scanners, they really struggle to identify commercial or proprietary components buried deep in that binary. They just can't see the ingredients anymore.
So we have a situation where the government is saying you must certify exactly who made every single ingredient in your cake, but the only tools you have are designed to look at the finished cake and guess what flavor it is.
That is the perfect analogy. It creates this dangerous gap between what the government requires, certify everything, and what the tools can do, only see the open source.
So relying on those old tools is basically guessing. And guessing on a federal Declaration of Conformity sounds like a really bad career move.
A very bad move. If you sign that document based on a guess and the BIS audits you and finds a Russian driver embedded in your braking system, the fines and legal repercussions could be catastrophic. You have to move from inference, from guessing, to evidence.
Okay, so how do we fix this? If we can't analyze the cake after it's baked, what is the alternative?
You have to be in the kitchen while it's being made. This is the concept of software provenance at build time.
Build time, so catching it in the act.
Yes. Instead of scanning the finished file, which is just an inference, you instrument the build process itself. You are observing. You're recording the source files, the libraries, the tool chains, the configurations as the software is being constructed.
Before it gets mashed into that binary blob.
Exactly. You are capturing the list of ingredients as they go into the bowl.
One of the sources we looked at for this deep dive highlighted a specific solution for this, a company called RunSafe. Their approach seemed to focus pretty heavily on this kitchen concept. How does that fit into the compliance puzzle?
RunSafe is interesting because they focus specifically on generating these detailed build time SBOMs.
SBOM, that's a software bill of materials.
Right, the list of ingredients.
Yeah.
But it's not just any list. Because they're watching the build happen, they can identify those commercial libraries that the post-build scans just miss.
They see the library being added to the mix before it gets hidden.
Exactly. They can show how a component got there, not just that it exists. They capture the build configuration, the toolchain inputs. It moves automakers from assuming compliance to having defensible evidence.
Defensible evidence. I like that term. It sounds like something a lawyer would love.
It creates an auditable artifact. If the BIS asks, how do you know this proprietary driver wasn't written by a prohibited entity? You don't just say, well, my scanner didn't find anything. You pull up the build time SBOM and say, here is the record of the exact file being linked during the build process on this date from this source.
It effectively solves that trust problem we talked about earlier.
Yeah.
You aren't just trusting the supplier, you are verifying the ingredients as they enter your system.
And that's absolutely crucial. The article by Joseph Saunders that we reviewed emphasizes this heavily. The goal isn't just to produce a list of software for the sake of it. It's to support those declarations of conformity. The idea is to embed the certification directly into the SBOM itself.
So the SBOM becomes the proof. It's not just a receipt. It is a certificate of authenticity.
Exactly. It's about creating a clear, auditable trail that can actually stand up to scrutiny.
This feels like such a massive shift. We spent so long worrying about hackers breaking in, the whole guy in the hoodie stereotype, that we kind of forgot to worry about who we were inviting in through the front door.
That is the core of the BIS rule. It is recognizing that in a connected world, the supply chain is security. You cannot have a secure vehicle if you don't know the origin of the code running.
All right.
You can build the strongest castle walls in the world, but if the bricks were made by your enemy, you have a problem.
So zooming out a bit here, what's the big picture takeaway? We have this rule. It's in effect. Automakers are scrambling. Is this just another hoop to jump through, or does it change things permanently?
I think it's a fundamental change in how we view software risk. The BIS Connected Vehicle Rule isn't just a regulatory hurdle. It is forcing the industry to prioritize transparency and lineage.
It's forcing us to ask where, not just what.
And for the automakers, the so what here is critical. The goal isn't to slow down innovation. Nobody wants to stop cars from getting smarter. But when they sign that Declaration of Conformity, they simply cannot be guessing. They need to know.
It prevents the I didn't know excuse.
It eliminates it. Ignorance is no longer a defense. And frankly, this might just be the beginning. Today it's cars. Tomorrow could it be medical devices? The power grid?
That's a sobering thought. Everything is connected now. If origin matters for cars, it surely has to matter for pacemakers.
I would bet on it.
You know, as we wrap this up, I'm thinking about the consumer. When I buy a car, I look at the fuel economy, the safety rating, maybe the warranty. I have never once thought about the nationality of the software running the brakes.
Most people haven't. It's completely invisible.
But it raises a really interesting question for the future. As geopolitical tensions continue to rise and as software becomes more tangible, a car is a physical thing that can hurt you. Will we see a shift in consumer demand?
What do you mean by that?
Well, we care about where our food comes from, right?
Mm-hmm.
We'll pay extra for organic or fair trade or locally sourced. Do you think we'll ever get to a point where software provenance becomes a consumer label? Will people want to know that their car's brain is locally sourced or maybe NATO certified?
That is a fascinating thought. Right now, it is a dry regulatory requirement. But trust is a currency. And if consumers start to view software origin as a proxy for safety and reliability, we very well might see certified origin stickers right next to the 5-star safety rating.
Free range code. I kind of like it.
Let's not get ahead of ourselves, but the sentiment is right. Transparency is the future. The black box era is ending.
Well, there you have it. The BIS Connected Vehicle Rule. It's complex, it's strict, and it's changing the way cars are built. It is not just about keeping hackers out anymore. It is about knowing who built the walls. A huge thank you to everyone listening. We hope this helped you unpack why origin matters more than ever.
Always a pleasure to dive into the details.
Stay curious, check your sources, and maybe take a look at where your software comes from. We'll catch you on the next deep dive. Goodbye.